This video is the beginning of Chapter 10, which is Molecular Geometry and Chemical Bonding Theory. We're going to be focusing on the molecular geometry. Molecular geometry is simply the shape of the molecule as determined by the position of atoms and lone pairs. The model that we're going to be talking about is called the VSEPR model. It's called VSEPR. And basically, we're going to be looking at the number of outside atoms, because all of these are assuming that we have an essential atom, like we did in the drawing of the Lewis structures. So we have a central atom and outside atoms, and then where the electrons, lone pair electrons, or unpaired or unbonded electrons are around the atom. Okay, and because electrons are all negatively charged, we want to, therefore they repulse each other because they're negatively charged. We want to keep lone pairs or electron pairs as far apart as possible because of the fact that there's a natural repulsion there. When we look at molecular geometries, we're going to be looking at, again, what's around the central atom. Okay, this is all based on Lewis structure. And so we're going to look at the outside atoms and lone pair of electrons. And there are 5 classes. First is linear, second is trigonal planar, but this actually this slide here shows all 5, okay? So linear, okay, trigonal planar, tetrahedral, trigonal bipyramid, and octahedral. So I basically call all of these the class or family that they're in. It's not going to be the answer that I'm looking for. Okay, so it's also this one, and that one. Okay, so there are 5 classes that come together. And then we're going to be looking at the molecular geometry inside of that. Okay, and so the 5 classes are, as I said, the linear. Okay, and so there's only one shape that goes with linear, and it's got a central atom. The A is the central atom, all of these, and then 2 outside atoms. Trigonal planar has a central atom and 2 or 3 outside atoms. Tetrahedral, okay, central atom and up to 4 outside atoms, or the smallest I can have is 2 outside atoms and 2 lone pair. Like I said, I have to have 3 in order to have a shape, okay? And why do I have to have 3 to have a shape? If you go back to thinking about graphing something, okay? So I have a graph. I'll make it fairly large. And as long as I have 2 points, I can draw a straight line between those 2 points. Whenever you're doing science, you have to have at least 3 points. So if I had this, okay, those green lines are not a straight line. Okay, in order to see if I have a straight line or not, I must have at least 3 dots in which I can draw a straight line through. So in order to have a shape, I have to have at least 3, okay? And so that's what I'm basing that on. Now I'm going to go back to the slide I skipped. Here's an example of 2 different models, okay? So boron, this is it says right here, BF3, okay? And if I was drawing the Lewis structure of this, okay, I would have an boron with 3 fluorines around it. Boron is an exception to the octet rule in the fact that it's happy with just 3. Okay, so the way that I'm going to classify this is having 3 outside atoms and 0 lone pair. And the big thing is the fact that when I draw the structure, it has the angle between these bonds is 120 degrees. This is phosphorus trifluoride, PF3. And so P is still my central atom. I have my 3 fluorines around it. But this one also has a lone pair. So even though it's not drawn here, there is a lone pair. Okay, so these 3 things I'm calling outside atoms, and I abbreviate that as OA. And then I have this, which is a lone pair, and I abbreviate that as LP. Okay, So the way that I would designate this one over here is I would say that this has 3 outside atoms, 1, 2, 3, and 1 lone pair. Okay, so it has 3 outside atoms, 1, 2, 3, and then the lone pair is this right here. Okay, so you don't need a 3-dimensional drawing of these in order to get this shape in molecules. All right, so there's my classes. This is again 3-dimensional. So this is, I like this balloon model. Okay, so again, these are just the classes. And in these, okay, the knot that's tying the balloons together represents, oops, I can't see it down there. Let me say it up here. Knots tying balloons. Represents the center atom or central atom. Okay, so the blue and the green balloons are outside atoms. Okay, so here I have my center atom and 2 balloons. The example of that's carbon dioxide. Trigonal planar, okay, these are all flat right here, okay, and so I have 3 outside atoms. All of these have 0 lone pair. Tetrahedral, so this you see lays flat. These 3 bottom balloons are actually slightly pointed up. You see that here, okay, and then one coming up. The trigonal bipyramid was if I take this shape and put a pyramid on the top, or one on the top and one on the bottom, that's what I get. So I get 2 pyramids that are a triangle shape, and then the point is up and down. And an octahedral, which stands for 8-sided. So this is trigonal bipyramid. So trigonal is the base, and then there's 2 pyramids. Octahedral means 8-sided, so there's 8 sides to this when I draw this out. Okay, there's 4 on top and 4 on the bottom. Okay, and so I have a square pyramid. It's kind of easier to see it here. I have a square pyramid. So here's my base is a square, and then the pyramid, 1 stacked up, 1 stacked down, and that's what it looks like 3-dimensionally. Okay, in the next video, we'll start going across more of these